We're going to transition now to a quick round of lightning talks by students and former students who've really drunk the Kool-Aid and figured out how to deliver on the promise of solutions that make a difference. These are going to be really short talks. I'm going to introduce everybody first, and they're going to zip through them, so you need to fasten your seatbelts. First, Jenna Forsyth is a research scientist at the Stanford School of Medicine. She's also affiliated with the King Center for Global Development, the Woods Institute, and the Stanford Doerr School of Sustainability. She completed her PhD in 2019 from the Emmett Interdisciplinary Program in Environment and Resources. James Kanoff is a 2023 graduate from the Stanford program excuse me, in symbolic systems. He was a founder and CEO of FarmLink, a nonprofit movement to transform the food system, and of Terradot, a science and technology company building gigaton-scale carbon dioxide removal. Third, Rwaida Gharib is a second-year PhD student in the Emmett Interdisciplinary Program in Environment and Resources. She's worked in humanitarian aid and international development for more than 15 years. Her research is on climate adaptation and resilience of vulnerable populations. And then finally, Charles Yu-Chen Shi is a Stanford undergraduate, class of 2025, majoring in international relations and symbolic systems. His class project on helping communities access disaster response resources is quickly gaining attention at the national scale, and it's really beginning to make a difference in people's lives. So join me in welcoming all four. Jenna, the floor is yours.
All right. Thanks so much, Chris. And so my story starts with my PhD. I arrived at Stanford thinking I would focus on water and sanitation issues. And after several meetings with my advisor, Steve Luby, I became really concerned about lead poisoning. Lead is one of the most toxic elements to human and planetary health, and it causes harm everywhere it's found. So this includes millions of premature deaths per year. Steve and his collaborators, including Scott Fendorf, Roz Naylor, I see some others there, as part of this Woods Institute-funded EVP project, had started working in Bangladesh, and the goal was to assess lead exposure among a representative population of pregnant women in Bangladesh. After I reviewed the preliminary data, I was just struck by these surprisingly high levels of lead poisoning, so more than 6 times higher than in Flint, Michigan at the peak of the water crisis, but with no obvious cause. So I traveled to Bangladesh and started working with our local collaborators, and we were trying to get to the bottom of this mystery. We conducted a series of studies, and one of these studies exploited lead's unique chemistry. So lead has 4 different isotopes, and the ratio of these isotopes can serve as a fingerprint of lead's origin. And this can be used to determine if the lead in the blood is coming from paint, cosmetics, or some other source. Our hypothesis going in was that the lead was coming from agricultural chemicals, but as we discovered, the lead was coming from spices. So turmeric processors were adding a leaded pigment to the turmeric roots to give them a more vibrant yellow appearance, and this had been going on for decades. So once we had the source, we worked with the government on a nationwide intervention, and this involved raising awareness and improving detection, and finally enabling the government to enforce an existing food safety policy and fine sellers of tainted turmeric. Within a few months, we saw a 90% reduction in lead-tainted turmeric, and within a couple of years, we didn't find detectable lead in the spices in Bangladesh. So this was incredibly exciting. What basically started as a Woods-funded project and a curiosity within that became my entire dissertation, which became my postdoc, and now is the focus of my career. So today I am overseeing this research initiative at Stanford to address global lead poisoning, which we now call Project Unleaded, part of the Human and Planetary Health Center. And we've expanded beyond Bangladesh. So our research shows that hundreds of millions of people are still, unfortunately, consuming lead-tainted spices. We've also expanded beyond spices, so we're applying this scientific framework to identify and prioritize sources of lead poisoning elsewhere. And I recently attended the UN General Assembly event where USAID Administrator Samantha Power called out the importance of our work in this global movement toward a lead-free future. This was an incredible honor and also just provided more motivation to remain committed to generating more evidence and advancing tractable solutions in the years to come. So thank you so much for the initial seed from Woods.
Thank you so much for inviting me. We actually started this project in a Hacking for Climate class that I think was the inaugural year that Chris was leading, and got to work with Scott Fendorf in independent studies and also David as an advisor. So it's really great to be back here. As you know, the world needs billions of tons of carbon removal to avoid a climate disaster, in addition to all of the decarbonization that we need to do today. And I think some people say that the best time to start on carbon removal was 20 years ago. The second best time is right now. One of the interesting things we learned from our Earth system classes was that Earth does have a natural carbon removal process. It's called the silicate weathering cycle, and it's been regulating Earth's climate for the last really billion years. You can actually look at like graphs of CO2 levels in the atmosphere, and you can see things like volcanoes that would release a bunch of CO2. And in parts when mountains form, you can see that rock weathering process. So when rain hits these rocks, the rocks weather or dissolve, release cations that bind with CO2, and you can actually see that CO2 going down. It's just going down over a really long geologic time. And so the question or idea we had is, what if we could speed that process up? What if we could take those same rocks, crush them up to increase their reaction surface area, and spread them on cropland where it'd be warm and wet, and it could increase that reaction rate? And it just turns out that if you could do that, you could start to remove carbon in years instead of over millennia. There's billions of tons of this rock. It's basically lava rock that we use. There's millions of hectares of farmland. We already have all of the crushers, spreaders, haulers, all the things exist for this solution to work. But there is one really big gap, which is that it's really early. We have really little data of like empirically showing that this works, but we have models that might show this. And so we ended up founding the company to try to accelerate the collection of that data and that research so that if this is a viable carbon removal solution for the world, we can figure that out as quickly as possible and then start to scale it up. So where we are today, we've partnered with the Brazilian government's research agency, Embrapa, and we're conducting one of the largest enhanced rock weathering field trials in the world. You're adding micronutrients to the farmers to help boost crop yields and hopefully removing carbon along the process. We're still like deeply working with Stanford, and a lot of the folks here, your advisors, part of the company, are just helping out, and really so grateful for this community that's actually helped make this possible. Thanks so much.
There they are. This beautiful family behind me is Mohammed Rashid and 3 of his 5 kids and his wife. They are Somali refugees that I met in a refugee camp in Kenya. Last year, 100 million people like Mohammed and his family were forced to walk across the Somali border into Dadaab, leaving behind their homes. And what choice did they have? After 5 consecutive failed rainy seasons, their crops withered, their livestock died. It was either stay and face starvation or leave everything behind and try for a better future. And this isn't unique to East Africa. In Pakistan, devastating floods have pushed millions out of their homes. In Guatemala, back-to-back hurricanes have destroyed homes and livelihoods, forcing families to make the journey north. And here in California, thousands have fled unprecedented wildfires, leaving behind entire towns. This isn't a scene from a distant future, it's happening now. Last year, 32 million people around the world were forced from their homes by climate disasters. And behind each of these numbers is a story of loss, of resilience, and of the urgent need for solutions. I shared this with you today as we celebrate Woods Institute's 20th anniversary. 20 years of creating solutions and building hope for these kinds of communities. That is, in fact, why I came to Stanford as a PhD student to study the plight of climate refugees. My research sits at the intersection of climate science, law, public policy, and human behavior. Understanding it requires expertise not just in weather patterns, but in immigration law, international policy, and economic development, mirroring the School of Sustainability's interdisciplinary approach, philosophy, and mission. During my first year here at Stanford, I noticed the gap in our curriculum. Despite this growing need for research on the issue, we've no dedicated courses on climate migration. When I approached my advisors, Chris Field and Janet Martinez in the law school, their response was immediate and characteristic of the mentorship that makes Woods a true catalyst for change. Together, along with a small group of other passionate students, we created Stanford's first dedicated course on climate displacement. We brought in guest lecturers from across the country and, importantly, across disciplines. We brought in legal scholars on refugee law, White House policy advisors on climate justice, New York Times journalists on public understanding, and practitioners sharing real-world experience from the front lines. The response from students was overwhelming. More than 40 students registered and dozens waitlisted within a few hours of the course opening. And this confirmed what we already know. Young scholars are hungry to understand and address this complex issue. And we were able to confirm this again when, in partnership with business school, we ran a parallel 2-day interdisciplinary conference on climate mobility, inviting scholars both here at Stanford and around the world to share their research impact and investigations for over 100 participants. As we look to the next 20 years of the Woods Institute's work, we have a critical choice. The data shows that the next 2 decades will no doubt force people to continue to move, like Muhammad and his family, as the planet continues to warm. These data represent families, like Muhammad's, communities, and cultures at risk. The path forward on issues like climate migration may not be clear, but that's the beauty of Stanford. Where there isn't a path, we have the resources to create it. Thank you.
I feel incredibly honored to be on the stage right now. Thank you, Leah, for nominating me to speak today. Last month, Hurricane Helene tore through the southeastern United States, resulting in hundreds of billions of dollars in damages and over 250 lives lost. Nearly half of which was in the state of North Carolina, where the storm shattered the state record with damages amounting to over $53 billion, a threefold increase from the previous record in 2018. In North Carolina itself, Helene affected 6,000 miles of roads, 126,000 homes, 220,000 households, and ultimately resulted in the deaths of over 100 people. Its western inland towns like Asheville were previously thought of as, quote, climate-safe havens, but recent storms show the reality that nowhere is safe from the impacts of climate change. My name is Charles Shi, and my dream is to leverage human behavior and technology to empower people to fight climate change. Last year, I took a Woods Institute course, Hacking for Climate and Sustainability, where we interviewed 100 academics, local, state, and federal officials on issues of climate resilience. We were able to use our course funds to travel to the National Adaptation Forum, where we met with government officials coming from small tribes and towns all the way up to the EPA, FEMA, and the White House. What we found was a $1.4 trillion opportunity from the Biden administration on climate change, but a devastating gap in how those funds are dispersed to the counties, cities, and communities that need it the most. At the end of our 10-week class, we built Eris, an AI-powered software platform that we designed to address this funding gap. On October 1st of this month, my project team won a High-Impact Technology Award through Stanford's Office of Technology and Licensing. Thanks to the energy of my hyper-ambitious friends and roommates turned project partners, we are the first ever primarily undergraduate team to receive this honor, and will use the grant to bring AI into the hands of communities on the front lines of climate adaptation. Through the help of the Woods Institute, we were also able to connect with Duke University's Nicholas School for the Environment, where we just got off a call 1 hour ago, kicking off a potential real-world pilot of our technology with Duke and North Carolina's Office of Recovery and Resiliency. In an especially trying time for North Carolina after these hurricanes, it is a surreal experience to be able to work this closely with them on solutions that will shape our future. Recent disasters such as Hurricane Helene show the importance and urgency of all of our work to mitigate and adapt to an ever-changing climate. We need to do so and break every barrier along the way. Thank you.
All 4 students did a spectacular job of staying on time, and we actually do have time for a couple of questions if anybody would like to ask one. And there are microphones at the back of the room. I don't know, do we have another mic we could pass among the speakers? Give us 1 second to get a mic up at the front. Question from the audience. Let's see, one from Rob.
I have a question for Jenna. So you referred to spices. You specifically called out turmeric, but what other spices have you confirmed to be tainted or might be tainted? And what risk, if any, is there outside of Bangladesh, either regionally or even as close to home as the US?
Yeah, thanks, Bob. Can you hear me? I'm not sure whether you can.
He just has to bring it up.
Oh,
It's
yeah,
a-
that's what it's on. Okay, great. Okay, great. Thanks, Rob. Yes, so turmeric, because of its color, definitely, there's a lot of turmeric we're seeing. We have research across South Asia that shows India and Pakistan have issues with lead chromate adulterated turmeric that's coming up again and again. There are other spices we've looked at. There are some spices used in, definitely the spice mixes. There are some colorful spices actually out of the Republic of Georgia, a small country, but that had an outsized issue with lead chromate adulterated spices. So thousands of times the kind of safe limits in those spices, things like called marigold flower and a combination of those spices. We've probably seen the news about cinnamon. There was kind of the first ever report of lead chromate adulteration in cinnamon from Ecuador, which is very unusual. So I think the problem is when these lead chromate pigments are available, they get used. It's not malicious. It looks like a nice bright color. It's not clear. It's not food grade. There's poor labeling in that supply chain, so that's an issue there. So to the extent to which it comes into kind of the U.S. supply, I would say from formal channels, we see very little of that, but there's a lot of hand-carried spices and a lot of cases of lead poisoning from public health departments from these hand-carried spices from abroad. Yeah.
I see George in the back there.
This is for James.
Actually, could you wait 1 second for the microphone?
Your approach and your company sounds like such a win-win, and it's going to take a ton of scale. What kind of team do you have? How you built out the business thus far?
Yeah, we're a team of about 30 full-time folks. It's mostly scientists and engineers and a couple of business people. But we have a really long way to go in developing this technology. Well, the simple idea is so it's like crush this rock, spread it on cropland, boost yields, remove carbon. Sounds really good, and it could be, but it's really early. Measurement and verifying how much carbon is captured is really hard. Getting it to be optimized so that it efficiently removes it is really hard, and that's what our team is working on every single day. But it is our hope ahead of COP30, which will be in Brazil, that hopefully this large pilot that we're running with the Brazil government can be on show, and maybe it's something that other governments around the world could start to adopt, and maybe we can start removing just a little more carbon.
One more?
All right, is this on? Turn it on? Can you hear me?
Yep.
Okay, perfect. So this is also for James. Are you guys looking at the impact of the microbial life and everything in the soil as well? And is this more like a sand, silt, clay, rock, dust kind of? Okay. So could you elaborate a little more about what you're studying? Because yeah.
Yes, we're actively monitoring how this affects soil health, crop health, and nutrients. Scott Fender, who's sitting in the back there, is one of the co-founders and I think leads the soil and environmental biogeochemistry department here. And so soil health is like a central thing that we are working to monitor. I think what's really encouraging for us is if you look back like a long time ago for a lot of soils that were depleted of a lot of these micronutrients, communities, be it like the Aztecs, even the Romans, were crushing up rock and adding them back into the soil to add in those nutrients. And so there's like a long history that extends past just this current agricultural age.
We have time for one more question right in the middle there.
My question is for James as well. Sorry. So
Not to gang up on you.
no, it's a very not unimportant question compared to the others. But in terms of industrial feasibility, seems to me like you founded a company around this, which tells me you're going as a competitor to currently existing direct air capture systems. What is your edge, you think, as much as not protected by IP? What do you think this system's edge is over the direct air capture systems?
Yeah, so I think the first thing is we need kind of everything under the sun right now to have a chance at hitting these targets. For carbon removal, I think we're like 1,000 times behind where we would need to be on track for the IPCC's goal. And so the more shots we have on goal, the better. One of the reasons this shot on goal is interesting is because we don't have to build anything new. So we have all this infrastructure, so that means that like the cost of doing this is actually like pretty reasonable. It's cost effective. It has a lot of these benefits of potentially improving agricultural yields, and so, or at a minimum just being a substitute for other pH management practices like lime, which means that possibly state department or like ag departments might be willing to adopt this. And so if you look at just like what is the budget of the world for carbon removal right now, very low. The budget for ag subsidies is really high. 2% of agricultural subsidies applied to rock weathering, applied in the right way, could be almost 1 billion tons of carbon removal. And so I think that's part of the advantage of this is we might be able to adopt this solution without even building a budget for carbon removal.
Okay, we take one more. Yeah, I would love to take one more that wasn't for James, but James' answers were all brilliant. Actually, you just wait for 1 second for the microphone.
Thank you so much. I love that your roommates are hacking together an AI solution. I just want to understand a little bit more about it. So there's a disaster, like what happened in North Carolina, and then there's a lot of money in the government administration, and you did what exactly with AI?
So there's, the way I like to think about this is there's short-term things that you can do, prior or after a disaster that, can help a government or can help a community, and there's long-term things as well. So the solutions that we're trying to pilot with North Carolina, for example, would help them, decades down the line. Essentially, there's a lot of resilient infrastructure that needs to be built out throughout the United States. Talk about seawalls, like elevated roads, etc. And we really think that there's an opportunity to bring AI to help streamline those processes to fund those types of infrastructure.
Well, after a series of presentations like this, it's easy to feel like the world is in incredibly good hands. So why don't you join me in thanking James, Jenna,